I'm really excited about the next part of our event. This is when we get to hear about some very exciting startups. Some of them are affiliated with CMU, some of them are Pittsburgh Regional, some of them have come in from outside the region, and they're from a wide variety of domains, market sectors, and so on, but all in the energy, climate tech, clean tech kind of space. So you'll see the theme as we go through this. So there are 19 companies. We're going to rapid fire go through them. And we're going to have a pitch, Q&A with our panel of investors, different panel than what you saw before, and I'm going to introduce them in a second. So pitch, Q&A, pitch, Q&A, pitch, Q&A, and then we're going to disperse, and there's going to be one-on-one meeting time between multiple investors in the room and all the companies that pitched. So if you're an investor, make sure you have access to the Google spreadsheet where you can go in and sign up for your one-on-one time. This whole thing doesn't make a lot of sense if the investors don't sign up for the meetings. Sign up for the meetings. So our panel now is three people. Christina Marullo from Energy Foundry came in from Chicago for this. Castle Jones from Rose Rock came in from Tulsa, Oklahoma. And Hong Kai Hei, Cahill Ventures came in from Boston. So let's give them a quick hand. And I'm going to ask each one of them just to give a couple sentences about themselves and their fund, what kind of things they invest in, what stage. And please, do you want to start, Christina?
Sure. Hello, I'm Christina Marullo with Energy Foundry. We're an early stage clean tech VC based out of Chicago. We invest in the seed and Series A round, typically one of the first institutional investors into a round. And we invest across clean tech, so our name's Energy Foundry. We obviously have a large focus on energy, but we're thinking about all of the concentric circles around that in the sustainability realm. We are tech agnostic, so we can do hardware, software, material science, and I'm looking forward to all of the great pitches today.
Is mine on? There we go. My name is Castle Jones. I'm the managing director of Rose Rock Bridge. Rose Rock Bridge is a newly launched energy tech startup incubator based out of Tulsa, Oklahoma. So we provide up to $100,000 of non-dilutive funding, office space, startup support services, and connections to our corporate and capital partners for startups that we try to attract to the region. Their only requirement for all of that is that they spend 1 year in Tulsa. And one of our members in the incubator is a seed stage fund called EIC Rose Rock, and generally look at anything that is energy or energy adjacent, but even more interesting if there's a strategic partnership opportunity with one of our local Oklahoma corporates. But really excited to be here, and thank you for having me.
Hello. Hi, my name is Hong Kai. I'm from Boston. So Cahill Ventures is a Boston-based deep tech fund. So we started to invest since 2017, focusing mostly on like breakthrough technologies or deep tech. So we are sector agnostic, so we do a lot of like tech transfer type of companies. From their first round, like usually the initial check starts from $500,000, and then we do reserve for 1 to 2 million to follow-ons on their deals. So we are, like I said, we are sector agnostic, so we do biomaterials like automations, computations, different type of things. And a lot of our portfolios have applications in ESG related, energy related things. Yeah, great to be here. Looking forward to the pitch.
Thank you all, and thanks for being here. We really appreciate your involvement in this event. So the next slide up here is the order of presentations. If you're one of the presenting companies, you've been asking me all morning what the presentation schedule is. This is it, assuming that everyone's in the room. So the way this is going to work is we're going to call the first person up, Brian from Module. He's going to do his 4-minute pitch. Cody over here in the corner will hold up a 1-minute sign when you have 1 minute left. He's going to hold up a time sign when you're out of time. If you haven't quit talking at that point, I'm going to lunge at you from my chair there. Then we'll have 2 minutes of Q&A, and then you'll leave the stage. Caitlin will come up, advance the slides for the next person. So you don't need to like find your slides. Caitlin's going to be doing that for you. So no further ado, Brian from Module.
All right. So my name's Brian, I'm the CEO at Module, and welcome to all the folks who are coming in from out of town. Welcome to Pittsburgh. So we started the company with a mission that everybody deserves to live in a space they're proud to call home. And we have a lot of issues around housing and real estate, and if anybody's tried to buy a home in the last 12 months, you've probably seen the crazy interest rate hikes. But we have a huge shortage of supply, so we're short 4 million homes. We have a huge shortage of labor. 40% of the construction workforce is going to retire in the next decade. And then the way we're building new buildings is making our planet worse. So it's a three-headed problem, and we're running at a cliff. So we've developed a building system that's a scalable way to deliver better homes anywhere. What it is a modular prefabricated construction system with a set of standard designs, a network of manufacturing facilities, and together, with those two components, we're going to be able to deliver thousands of units to people who need new, affordable, attainable housing that's climate ready. So this is the product. It's like big Lego blocks. It costs about $150 a foot. So the foundation's built by a traditional contractor. And then what you see being lifted with a crane is actually built in a factory and installed with a crane, and that happens in about a day. So we can really vastly reduce construction times. So it's an all-electric product. We can build 40% faster. We can build 80% more energy efficient than your average home on the market. And we have a 10% lower life cycle cost. No idea if this video will play sound, but let's see.
So this home received a certification from the Department of Energy, and it's a zero energy ready home. So this house is all electric. There's no fossil fuels powering the house. Solar panels can be added very easily to go net zero.
I think my favorite thing about the new home is the fresh air vents that I have, where it generates the air from outside and brings it in. It's always fresh air in the house. It's beautiful. You don't even have to open the windows or doors if you don't want to. I just do to hear the birds and the squirrels, but I love the air. Came to the tour and I saw the house and I was like, this is fabulous. I saw how it was made. I saw the love and care that was put into it. And I love working with Module, so I was like, it's time for me to try this out. I would say that it's a beautiful house. Every day I walk in my house and I say, I am so happy to be here. I love it. It's probably the best part of my day is coming home and like, I live here.
So that's a kind of a quick little customer testimonial, but what we do is we have a standardized product. So we've developed a number of designs kind of similar to what you saw in that video for infill housing, so housing in cities, in urban areas. We've developed a standard operating procedures and a playbook to help local contractors install these homes. And now we're building out a network of delivery partners. And so our customer is actually business to business. So we work with developers. They hire us to design the product, manufacture it, install it. And so we've lined up a network of contractors, architects, and other folks who help us make that a reality. And as I mentioned before, we can produce a home 40% faster and 80% more energy efficient. And that's putting about $1,600 a month back in homeowners' pockets. We've delivered about a dozen units to date, and now we have a pretty sizable pipeline. So we have about 21 million in our pipeline right now, and that's with mission-driven developers. So what we're doing is we're serving affordable housing developers who are building new market rate and affordable and low-income housing in their neighborhoods. Our long-term strategy to expand and go to market is to be opening up these urban micro-manufacturing facilities. So the first one will be here in Pittsburgh, and we were contracted by Fannie Mae to look at how we might take this model on the road. And this is our team. I'll take any questions.
Sure. Let's see. I'd love to learn more about the types of regulations that you had to meet in order to ensure the safety of the buildings.
Great question. So people hear modular and they think, oh, it's a mobile home or a manufactured home. And that's actually a separate building code. So you have International Building Code, which regulates modular construction and traditional construction. And then you have HUD code mobile homes. So that's a separate building code. So we're building to the same standard that an average home builder in your neighborhood would be building to. The difference is everything that's built in the factory is inspected by the state. So instead of a local building inspector driving up to the factory to see it, the state actually inspects it, puts a seal on it, And that actually makes for a faster permit time and a faster inspection time on the ground once the units are delivered. But we're building to the International Building Code standard.
Thank you.
I'd love for you to finish the point I think you were about to make, but what does it look like to take what you build here in Pittsburgh and scale that? So what does the customer acquisition strategy look like? How are you identifying the communities that you want to go after and those developers?
Great question. So we love Pittsburgh, it's our hometown, but Pittsburgh's population isn't growing off the rails, right? So we're actively looking to expand into the mid-Atlantic. So right now we're doing feasibility studies in Prince George's County, Maryland, and in Virginia about what is the demand there. So we're speaking with developers through this contract with Fannie Mae. We're now getting in front of 50 to 100 developers who are looking for a better solution to build new housing in there because they're struggling with the same labor challenges, right, that every developer has. And then we're also talking to local jurisdictions about what would it look like to bring jobs in manufacturing and workforce training. So that's right what we're doing right now. All right. Thank you.
Hello, my name is Ian Magazine. I'm CEO of AirViz. And a huge thank you to the incredible startup ecosystem here at CMU. AirViz is a CMU, proud CMU spinoff. We're developing proprietary, advanced, and scalable enterprise-grade air quality monitoring at a fraction of the cost of traditional equipment. Here we go. With 99% of the global and 92.8% of the US population breathing unhealthy air, and air pollution being a major contributor to climate change, government and industries are investing heavily in improving air quality. AirViz cutting-edge technology provides smart solutions for cities, industries, and buildings. Our SaaS, or Sensing as a Service solutions, backed by 7 issued patents, mitigate and manage air pollution risks, protecting people and assets. AirViz's game-changing sensors and software transform low-cost IoT devices into high-performance air quality monitors. And our solution goes beyond gathering data. We use predictive and prescriptive analytics to show what could happen, where and when and how to intervene, empowering decision makers not just to solve problems, not to just identify them. In the rapidly growing carbon offset market, projected to reach $1 trillion by 2037, AirViz provides monitoring services to help the world achieve net zero targets. AirViz has teamed up with a global carbon credit leader that plugs abandoned oil and gas wells worldwide. AirViz's sensors will be used exclusively for 7 to 15 years to monitor air quality and methane emissions. And there are over 300,000 abandoned wells in PA alone, 3.2 million in the US and 20 million worldwide. Air quality monitoring is critical to creating smart cities, yet 79% of US counties lack a single reference monitor due to its high cost. As a result, most pollution risks go undetected. Our low-cost sensors and data analytics offer a cost-effective solution to monitor air quality on a hyper-local level. AirViz works with the city of Pittsburgh and in Miami-Dade County and is partnered with environmental testing labs with lucrative government contracts. Our upcoming pilot with global and chemical materials companies present a great opportunity to provide monitoring services to help industrial facilities comply with regulations. AirViz technology has been installed in thousands of residential and commercial buildings worldwide thanks to our collaboration with 3M. Our management includes air quality experts and a technology and commercialization team with a successful track record of creating multiple early-stage companies. Our advisors consist of business leaders, 3M and Infosys, who are also investors in the company, academia at CMU, University of Rochester, and government, including the former CTO of the Department of Energy. At AirViz, we have the right team, timing, and execution strategy to generate meaningful returns and make a real difference in creating a healthier future with cleaner air. Thank you.
Who's actually your client? Like, who pays for this kind of project?
So depending on the project, so smart cities, the cities pays for the project. For the plug oil wells, we have a partner who is committed to actually buy and pay for the sensors. Who am I missing? And for the pilots, it would be industrial customers.
Just a quick follow-up. Is this required by the regulation? Or like, what's their driving factors for them to spend this money?
What's the plan? What's the plan?
Why they would pay for this? Like, is it because regulations, or is it how do they calculate the ROI themselves?
Yeah, so specifically, I'm going to specifically, because there's a whole bunch of different sectors. So specifically looking at the carbon credit market, if we get 20,000 oil wells to be plugged at 50, just using some basic math at $50, that's a recurring revenue of $1 million a month.
I noticed that it seems like you were initially working with commercial and residential buildings, and I'd like to learn more about why you made the transition into the industrial segments.
Yeah, that's a great question. So our partnership with 3M, we provide the sensor that goes on their smart filter that actually tells you when to change your filter. But the real reason why is that when we work outdoors, which is a bigger challenge, that is a much bigger market. Plus, we would need to integrate into building management systems and software, which was a lot more challenging.
So thank you guys for having me here. I'm Allison. I'm the CEO and co-founder of BlastPoint. We build AI systems for industries that desperately need AI, but don't have it because of regulations or other obstacles. And for a lot of my customers, we are working with the backbone of the US economy. We work with utilities, we work with banks, we work with auto manufacturers. And they have all sorts of reasons internally that they're not already taking advantage of this technology. And in a lot of cases, we're the first AI solution that a lot of the teams we work with have ever used before. And so, it's our job to build bridges. And honestly, what we do is operationalize data. So if I gave my customers a spreadsheet full of numbers, they'd be like, thanks, I hate it. What we do is we give them roadmaps. So we take the information they need to understand their customers and connect it directly with value. And this is not theoretical for us. We are in market right now. In fact, with our utility customers alone, we cover 1 out of 10 US households. And that means all of the models we build are amazing. And we get real results for our customer, anywhere from turning around customer satisfaction scores within a month, understanding who's going to pay their bills and who won't, this December, next December, and what you can do to prevent that. And it sounds like we do a lot of different things. I'm a one platform, one product kind of gal. It is one AI engine that we've built, one software experience. My automotive manufacturer uses the exact same software as my smallest bank. And one of the things that really makes us unique is that we're able to do this at a rooftop by rooftop level. So not only do I understand, hey, who's going to buy an EV next year, the year after, 10 years from now, I know what their values are, what they care about, how to talk to them, and where to find them. And for us, we can do anything with our customers. We're laser focused on what provides them the quickest straight line to value through understanding their customers. So it's billing and payments, customer satisfaction. JD Power is one of our partners, and program adoption. So what products are they going to buy? What programs do they want to adopt? And the way we stand out from our customer or from our competitors is not only do we have a patent that was issued covering the way we handle our data, the way we present data, we also are designed for teams who are brand new to AI, especially any industry where like the graves of CTOs are built on adding AI to any kind of infrastructure. We want to go to the places where it's hard, where it's brand new to people, and where it's going to provide the most effect. And our selected target markets are huge. We've already got a market leader reputation inside the utility sector. We're doing the same for banking, commercial services, and we have over 23 verticals where we know we could have applications. I have an amazing team. Most of us are Carnegie Mellon graduates. Myself and my co-founder, Tomer, we're both two-time Carnegie Mellon grads. He is an expert in machine learning and computer vision. My expertise is machine learning and computational linguistics. I think we have so much potential. We had a really great 2022. Our MRR grew by 276%. And I'm raising around right now. In fact, I have a lead. And if you're interested in joining us, helping us build something really big for the future, please come and talk to me. Click that button next to BlastPoint. I really just want to thank you guys so much for having me here, especially Reed, who made me come here. So thank you guys so much.
What's the revenue model for this? Is it subscription-based?
Yes, it's a SaaS subscription. Our proof of concept start around $50,000. Our largest customers pay $500,000 or more per year.
And where do you get the data from? Does the customer provide the data as well that you train the AI on? And
so we have an any and above data attitude. So for any individual household in the United States, we have literally thousands of points of data. Some of them come from our customers. Some of them come from our private data partnerships. Some of them come from proprietary data sets that we've built ourselves.
So is this somewhat like you customize to every client?
Pardon me?
Do you customize for every client?
So if we can, what we try and do is, that's the reason we focus on those three main use cases, so that everybody's kind of getting the same sorts of things over and over again. We like to think of ourselves like a Nintendo. Like you buy the platform, and then the cartridge will be different based on what your priorities are. But we're going to sell the same sets to all the same customers. Some of them are classics like billing and payments. That's our Zelda. Some of them are going to be brand new based on new U.S. regulations like electrical vehicle purchasing incentives. That for the last year and a half, our EV modules have been one of our most popular sellers. And in fact, that's one of the things our automotive manufacturer has, as well as our utility manufacturer. Exact same data.
You say that you target the really hard segments. What makes your team the best team to go after those segments, and why hasn't anyone tried to go after them before?
Yeah, so my background's in banking compliance. So I built software systems that found terrorists in the banking system. I've had customers in 40 countries before. I'm used to reading regulations. Regulations used to scare me, and now I realize that they're something that are an opportunity in a lot of cases. And it's our background in working with this. We also have a very, very intense cybersecurity practice inside the company, which is one of the other areas of our advantage. And in fact, our chief of security came from right here in Carnegie Mellon's Software Engineering Institute.
Thank you.
Thank you.
Hello, everyone. My name is Dr. Rajan Kumar. I'm the CEO and founder of Ateo Systems. Here, excited to talk about batteries. So essentially, batteries are basically a bottle of magic. They give life to your car, your phone, all the power to the electronics around you. The magic inside a typical battery comes from what's called an electrode. It's basically a film, a composite made of battery powders held together by polymers. What we're doing at Ateo Systems, we're innovating how to make these faster, lower cost, and better performance, enabling battery manufacturers to build better batteries. So basically, the way these batteries are made today, 50 years the industry has relied on very high temperature toxic solvents and extremely expensive gas guzzling ovens to manufacture these parts. Where basically these polymers, they need these high temperature solvents in order to dissolve and make this kind of polymer solution is then coated. This process is one of the biggest bottlenecks in the roughly $200 billion battery market. It's very slow because all this time to remove that solvent. It's extremely expensive in both CapEx and OpEx. To give you a context of what a gigacoater looks like in a gigafactory, it would be the length of this room, it would be 2 stories high just to support that tool. And because the way these materials are, it's limiting the ability to improve energy density. So what we've done is we have a solution where we use electron curable polymers. These are polymers that flow without solvent, and they instantly solidify into a dry film with the exposure of electrons, just an instant flash. Oak Ridge has patented this technology. We have the exclusive license, and this technology is proven to manufacture the key parts 10 times faster roll to roll. It's 3 times the reduction in OpEx CapEx because we shrink that tool to the size of this podium. And because of its materials, we can improve the energy density and really enable solid-state batteries. And what's really exciting, this process is chemistry agnostic. So you can impact any type of battery, from really tiny to EV batteries as well. So over the past 12 months, we have made significant progress in both our market, customer traction, and so forth. We've delivered batteries to over 20 customers. We've secured over $750K in NRE contracts from major customers in both commercial and DoD. Actually, that is a picture of our recent solid-state rechargeable battery that we delivered to the DoD in the middle. That was a battery that was shot multiple times by an AK-47, did not blow up and still operational even after being shot. And we have pilot technology with fabless manufacturing partners that can help us scale to over $500 million in parts. Okay, so basically, it's limited time here. Basically, we're raising $7.5 million. We've already have over $150 million in our pipeline. This facility, what we're doing is retrofitting an existing manufacturing that can fill this demand. And that's why we're here today. And we are confident that we can beat anyone in the space because we are incubated in a $15 million battery facility in Indiana. We have done that with raising less than $2.5 million. And very little in capital investment, our investor dollars have gone to capital investment. And then our team has over 100 years of experience in deep tech manufacturing. And so obviously, I don't have my information here, but you can email me, talk to me. What we're looking is for partners that will really help us enable this technology and enable the magic of batteries to last longer and be ubiquitous at all. Thank you.
You said that this technology can be integrated into the current battery supply chain. So then what's the biggest challenge to scaling that?
So, I mean, right now we haven't seen any challenges. We've been working with reputable companies. We sell them apart. They plug it in, die cut it, and assemble batteries as is.
And then for the other dry electrode manufacturing technologies out there, you mentioned that you're confident you can beat them. What's kind of the unique insight that puts you ahead of them?
So right now I see there's only 2 or 3 competitors. Obviously the biggest one is Tesla. So that's, I know, a very bold claim for me. But the reason we can do that, our material, that polymer, is far more elastic. And that's going to give that really enabled innovation for solid-state batteries. For other companies like AM Batteries that has done, they're looking at spray. The problem with spray is you're just not going to get the efficiency. Just imagine spraying very expensive cathode materials onto a film. You really have to prove you're getting over 90% efficiency. If you're not doing that, I don't know how you can get the cost down lower, even if it's dry. So that's why we know we can beat them. And I think the most important thing is our facility gives access to suppliers. We can R&D much faster. This is why we're getting a lot of DoD contracts right now, because we have our facility capabilities.
So you said you're agnostic to chemistry. Does that mean just solid state chemistries or all battery chemistries?
All battery chemistries. So, from EVs, actually this technology was proven at Oak Ridge with EV battery over 500 cycles without any loss of performance. And we've been really scaling up these disposable batteries that have really low technical risk, really high margins, and very fast sales cycles. We're scaling production with that, and that's going to lay the foundation for rechargeable batteries.
Thank you.
Yep.
Fantastic to be here. Thank you for giving us the opportunity to share our story. My name is Mark Kovsek. I'm a mathematician, class of 92, applied mathematics and industrial management. And 30 years later, I can tell you I still have PTSD from that ordinary differentials equation final. Our mission is to enable cost-effective and sustainable water use. Every year in the US, there's some by the way, this is my math joke. This is no ordinary set of prime numbers. Take a look at this. So 5 million gallons of water is what we lose every year to unwanted water use. To put that in perspective, that's enough water to nearly meet the needs of every home in the United States. That's a big enough problem in and of itself, but here's the thing, the built environment is the single largest contributor to carbon emissions across the globe. And here's a stat that you may not be familiar with. In most commercial properties, water is the second largest consumer of energy. We estimate that there's some 3 gigatons of carbon emissions associated with water use. But there's a big economic challenge associated with this as well. That unwanted water use represents about $100 billion every year. So we can't eliminate water use, but we can reduce it. And there's really only four ways that this can happen. We can improve the efficiency of pesky human behavior. We can increase the efficiency of industrial and commercial systems. We could eliminate or reduce what we refer to as everyday leaks and mitigate the risk of catastrophic leaks. Now, there are a number of solutions in the marketplace today that address these challenges. However, these solutions are incredibly expensive. They're not aligned with the value that's created. Many of them require a professional to install, and they don't offer data at high enough resolution to make meaningful or actionable change. We cracked the code. We invented a way to make a simple microphone, a $1 microphone, understand water flow with machine learning. If this was in your home, only a single sensor would be required, and we can actually not only tell you how much water is used, we can disaggregate that use and detect leaks, as well as with that high-resolution data, help drive awareness and even craft custom conservation recommendations, ultimately to reduce that water consumption. There we go. So what would this look like? Our go-to-market is commercial properties, and I like to use a 100-unit multi-family property, call it 10 stories high. We would monitor use across 3 major systems. Of course, there's domestic water supply, irrigation, and then building systems themselves. A building like this would take about 200 sensors and cost anywhere between $25,000 and $30,000 to install. It's a hardware cost per sensor and then an ongoing monitoring fee. Can create significant value. Our objective is to reduce water consumption across those buildings. And then if you're looking at this as a prototypical building, we see, and using about 15 to 20% water reduction, nearly 2 million gallons of water associated with that building. We will actually not only save in water, but waste and energy savings as well. The payback period is typically measured within 7 to 9 months, and there is a significant carbon impact to that reduction. In this building, it would be about 100 metric tons. And we're delivering this today from luxury apartments in LA to high-rise units in New York City, the Hall of Fame Village, and castles in the UK, and luxury apartments in Cairo. Last night, I returned from Dubai, where we won the opportunity to work with the country and some of their largest developers and property managers, ultimately with a goal to get to 100 properties a month. We are currently in 100 properties. We are across 9 countries. We're partnering with major OEMs, tech companies, telecommunication companies, insurance carriers. We only launched the product in 2021. We had sold 4,800 sensors last year with an objective to do 30,000 this year. The team of 20 and I invite you to participate in our mission to improve the planet for future generations and help drive net zero by reducing water consumption. Thank you.
So what kind of insight you can provide when you get those data?
I'm sorry, say again?
What kind of insight or actionable items?
Thank you. So look, when we're talking about it's a little bit different between human consumption and commercial properties and commercial consumption, but our favorite is human consumption and looking at this. Just with the Hawthorne effect, by creating water awareness and looking at daily usage, very simple things, we're seeing a 5 to even 20% reduction in water consumption. But the insights that we offer are, we know exactly how much time you take in the shower, how many times the faucets were used, et cetera. So with that information, we can start to craft those custom conservation recommendations. I'll give you a very simple one. In your household, you take an 18-minute shower. If you reduce that to 12 minutes on average, you will save $500 to $700 in water waste and energy costs this year. But what we found is it's actually even simpler than that. Just with a weekly email to residents in a multifamily property, just articulating how much more or less water you used, as well as simple things like the highest water use was on Thursday, where the highest use fixture is the bathtub. Just those simple insights, we're seeing a 20 to 35% reduction.
Where in the building are these being installed?
Yeah, I had a picture up there and I didn't articulate it clearly, but if this is in your home, it's on the pipe that comes into the property. We're not in homes yet. I mean, we are, but that's not our go-to-market. We're in these large commercial buildings. So in that commercial building, imagine that there is a room. There was a picture there that had all of these risers set up. We would be on those risers as one point of deployment. That offers a service level that is basic monitoring and leak protection, or we would be on every single unit in that property. So this sensor would be coming into that unit and offers a different level of resolution that would get more to the human behavioral change.
What's the cost of the sensor, and what's the
sensor? This is a sensor, and this is how it installs. By the way, it's like a wristwatch. Is $129 US, and there is a 36 annual subscription associated with the sensor. Thank you. Thank you.
What if I told you that this apple could be so much more than just food waste? Well, at Ecotone Renewables, we are sustainably converting food waste into powerful liquid fertilizer and renewable energy. My name is Dylan Liu, and I'm the CEO and co-founder of Ecotone Renewables. My background is in material science and engineering right here from Carnegie Mellon, with career experience working for NASA and GE Renewables, solving fleet-wide failure analysis problems for 50,000 operating wind turbines. This leads me well into my role as CEO of our hardware startup, where I'm focused on streamlining our operations and commercializing our products. Kim, shown in this ribbon cutting ceremony, is one of our customers and the brilliant owner of Plant City, a 3-chain vegan food hall based in Providence, Rhode Island. Kim is required by state law to have all food waste kept out of landfill, or she faces up to $7,000 in fines and repercussions from her customers. Kim used to pay $700 a month for a compost hauling service, on top of running a business in one of the lowest single-digit margin industries of food service. There are millions of business owners like Kim across the 10 US states that have already banned food waste in landfill. This is a global problem where food waste is costing businesses and consumers $2.6 trillion a year. On the impact side, food waste emits over 8% of global greenhouse gas emissions, which for reference is more than all airline industries combined. The problem is huge, and our solution is intentionally sized to solve it. The patent-pending Zeus system, shown right in the middle here, is an on-site waste processing solution for restaurants, cafeterias, and commercial buildings. 12 tons a year of food waste is inputted into the system through a trash chute, and 50 gallons a week of our signature soil sauce liquid fertilizer comes out for us to sell in large-scale B2B contracts at $10 a gallon. The system cost is $50,000, so it works out to under a 2-year ROI for a system with a 20-year lifespan. We are already generating revenue right here in Pittsburgh with contracts with the City of Pittsburgh, as well as 412 Food Rescue and the Food Bank. We just finished 3 simultaneous system builds, which are getting launched over the next few weeks for Meta, the Allegheny General Hospital, and Plant City. We are currently oversubscribed with 10 additional systems requested, including the Pittsburgh International Airport. We have an amazing multidisciplinary team, including Kyle, our COO, and an expert in human and computer interactions, Elliot, our CFO with a finance background and experience managing $6.9 billion in client portfolios, and Sasha and Carl, who are successful serial entrepreneurs who have grown companies now valued over $5 billion. Over the next 18 months, we're focused on expanded revenue generation up to $3 million by the end of 2024. Plotted here in blue is the number of Zeus digesters alongside revenue generation in green. We are currently raising a $2 million seed round being kicked off by the Richard King Mellon Foundation alongside 3 institutional investors. Summarized on the right are our 12-month milestones, which boils down to increasing and expanding our existing revenue streams, validating additional target markets, and unlocking a price Series A and debt financing to enable aggressive growth. Thank you very much for your time and consideration today, and looking forward to connecting more this afternoon.
What's our core technology here?
So we have 2 pending utility patents. One is on our overall self-contained anaerobic digester. So operates very similar to our stomach, using bacteria and microbes to digest the food waste. And we have a second pending utility patent that is on our waste sorting system. So we are automatically detecting and removing any impurities that get in the food waste stream, including plastic, glass, metal, and rubber.
So restaurants can be a segmented market. So how do you plan to scale in markets that can be kind of segmented?
Definitely. So our focus is very much on those 10 states with food waste bans to landfills. So this is a hair on fire problem for these customers. They're paying exorbitant costs to have compost haulers truck this food waste hours away from the city. And on the fertilizer side, we're already starting to expand that go-to-market strategy across farmers in the Northeast and in the Pacific Northwest. So those are our 2 regional focuses.
Which one's the, which one's the key revenue driver there? Is it the food waste processing or is it the fertilizer cells?
The revenue right now accounts for about 70% of our revenue generation, the fertilizer. And the biggest lever for that, I'll add, is right now we're selling $10 a gallon in large-scale contracts. We've started expanding direct-to-consumer sales, which is smaller bottles, but an equivalent of $240 a gallon. So that's one of the biggest revenue drivers and profit drivers we can have.
Where do you see a potential to exit your business?
So we've already started speaking with waste management as well as multiple firms, including PE firms, Caterpillar, John Deere, and starting to learn about the milestones that they're looking for. So ideally, you'll see us on the stock market in 5 to 10 years if we IPO, but we do see shorter term exit opportunities with strategic investors. Thank you very much, everyone.
Just a quick reminder to everyone in the room. I sent many of you, if not all of you, all of the investors an email to let you know that if you're interested in meeting with any of these folks who are presenting, I sent you a link to the Google Doc to sign up for those meetings. I encourage you to do so. If you see something exciting, sign up. We want to make sure that these startups have a chance to meet with you, and you never know what kind of opportunities might arise in a one-on-one setting. Thanks.
Mike Seifert from Steamlinks.
Great. Thank you for having me. My name is Mike Seifert, and I'm excited to introduce Streamlinks to you. So let's start with a problem that's been talked about quite a bit today, and that is the demand on our energy grid. Obviously, it is ever increasing for lots and lots of reasons. There's tons of federal programs that are pushing buildings to become electric, to decarbonize electric vehicles, all sorts of electrification of buildings. And then that begs the question, where is this energy going to come from? Well, renewables and power plants are part of that, but it's not going to happen fast enough. So most of that is going to come from energy efficiency. There are lots of companies out there doing this, hundreds of thousands of them. These are our clients, energy service companies, contractors, folks in the business that are supplying both materials and labor and expertise to actually make buildings more efficient up top in a number of different measures, lighting, controls, HVAC, the whole works. So you would think with that many companies doing this that there wouldn't be a problem, but there really is a problem. The complexity of these technologies that is coming out right now is so complex it requires a lot of data to be collected out in the field. It's got to be analyzed. Many people have to collaborate and many companies collaborate to actually produce these proposals, win the business, and actually facilitate the entire project all the way to fruition. So the tools that they use today are just really falling short. They're using paper, email, spreadsheets, a lot of moving the data back and forth. So it causes a big problem. That's where we come in. We've created a platform called SnapCount. So we automate that entire process from the data collection in the field on mobile devices. We integrate the entire workflow process for them to take that audit information all the way through proposal, win the business, and implement the project, produce the proper documentation for completing the project and finishing it out and getting paid. It's a platform to allow the collaboration with all the companies that are involved to actually produce that work. And ultimately, the data that's produced out of this entire system is the insight that they use to actually make their businesses more profitable. So what that does for our customer, it really increases their profitability, increases their capacity to do more of these projects, and obviously gives them more profit. So these are not just numbers that we're making up. This is real information. We have hundreds of companies, thousands of users on the system right now. Our Net Promoter Score says that these are raving fans, and they're out there promoting us to get in more business. So we've got real revenue, patent protection, and we've run real projects through this, taking energy off the grid. So that's a real win for our customer from a profitability standpoint and for the environment to actually remove that from the grid. So using that blueprint, we're going to move forward adding multiple measures. And each one of those measures is going to allow us to expand our market and actually expand what we can sell within each one of these companies. We got a good team of advisors and leaders to make this happen in software development, marketing, sales, and we anticipate this and project this to grow to 3 times our current revenue by the end of 25 by adding on these measures and expanding that footprint. So we are seeking money to do that. We know you can't just build it and they will come. We've got to have people to market it and sell it in each of these measures. So to recap, the energy market is enormous. We've seen that today. We've created a platform to accelerate this process through these contractors. Our customers, the industry players, win by increasing their profitability, and the environment wins by reducing the load on the grid. So thank you very much, and I'll take questions. Thanks.
How would you define your competitive moat?
Our competitors?
Yeah, like how your differentiator, I guess, from other softwares.
Yeah, our differentiator is really the full life cycle. There are many either in-house built products that people use that are just spreadsheets that might handle the front end of it, but no one actually handles, none of our competitors handle the entire life cycle from auditing in the field through creating the proposal, generating the proper efficiencies, and then actually tracking it all the way through fruition so that we can actually produce the documentation necessary to get paid and all that.
Yeah, I think another question on that is you say with your software, you increase project win rate 80%. What about your software allows contractors to do that?
Well, that's a great question. It's probably a couple-fold. One is there's a professionalism of coming out and gathering the data in a very logical manner. The data that we can then put back into the proposal, a very, very elegant and full proposal, allows them to differentiate themselves from their competition. So we find that people that are using SnapCount are winning a lot more business than the ones that don't have it, because we see them go head-to-head in the same facilities. So it's been a real win for them.
Is the revenue model subscription-based?
Revenue model is software as a service, so we're an annual subscription model, right?
So what's the price point for the software?
Well, the price point of the software will vary depending on which part of it they use. There's many modules allowing the customer to come in and various modules there. It probably ranges anywhere from 250 to 500 a user. Our average is somewhere between 14 and 20,000 a year for companies. Thank you.
Hi, everybody. I'm Brian Scott, CEO at Pitmoss, where we make soils out of all recycled material like paper and cardboard. Why do we do that? Today's soil system is broken. There are supply shortages. There are a ton of environmental issues because everybody today uses peat moss. 98% of the soils we import from Canada is peat extracted there. And lastly, it's poor performing material. Our solution is, as a regional supplier, helps prevent the supply shortages. We can eliminate the environmental impact related to peat extraction, and we get significantly better performance than our competitors. So we have a really positive environmental impact. We've helped prevent over 15,000 metric tons of carbon emissions already and helped save over 30 million gallons of water. We tend to get 10 to 50% larger plants with greater yields compared to our competitors, and we're a real company with real revenue. We did about $1.2 million last year. We're projecting $2 million in sales this year. We think the time is now for our product because of a convergence where there's an understanding that peat is a problem. People are looking for peat-free soils. We've got supply issues with it. Carbon emissions are a massive topic that wasn't nearly as big 5 years ago, and we're positioned perfectly to take advantage of all of these changes in the market right now. It's about a $20 billion market overall between soil treatment, regenerative ag, and the current peat-based soil market. This is what the current soil economy looks like. We extract peat from Canada, we ship it to the US where it's processed, made into soils and sold. We have a vision where we can have regionally focused factories that are using local paper and cardboard waste, turning it into soil that we then sell locally and regionally. There are a ton of competitors in the environment today. The key is that they're all using peat moss as their base material. So not only are we a competitive brand, we can actually sell them all the base material where they can use our product instead of peat moss. And we were also recognized this year as the best overall potting soil in America by Better Homes and Gardens. We're starting to already find people that want to integrate our product into their soil brand. So they're either white labeling with us or they're integrating us into their mixes. We have a full range of retail products right now, as well as grower products and also animal bedding. Our unit economics are at scale. We can make the product for about $1.20 a cubic foot. We sell today commercially for $2.50 a foot, at wholesale for $5 a foot, and retail for $10 a foot. Our technology is really disruptive. We have 1 patent issued, 2 pending, as well as a bunch of trade secrets around our feedstocks and formulas. We've got a really strong team, including one of the top soil scientists in the United States today. And we're at a convergence where there's a lot of positive things happening for us, including a lot of recognition on social media by some of the biggest influencers out there that are looking for peat-free solutions. There's a ton of exits in the space already. A lot of them go to Scott's Miracle-Gro, but we think that we'll be attractive to all of the peat manufacturers that are losing their business, as well as some other product brands and potentially cannabis companies. We're working now on a Series A fundraise, and I can go through a lot more detail. I'm about out of time, so I'll take your questions. Thanks.
Can you help me understand the soil market a little bit better? Is your solution the only peat-free soil, or is it just the best performing of those peat-free soils?
So there are a couple other peat-free options that are coming on the market, like Coco Core, which is imported from Asia, really expensive, a lot of water related to processing it, salinity issues. So wood fiber is starting to come on the market. It's got its own issues related to monocropping, poor performance, other issues related to that. So there are other non-peat products coming on the market, but we really outperform all of them. And the real disruptive part of what we're doing is being able to make everything regionally or locally based on paper and cardboard waste. So if nothing else, we can disrupt all the transportation that happens with all those other products.
How does your product perform better than, I mean, I always thought peat is like gold, right? But so how come your product performs better?
Yeah, it's simple. Peat is actually not a good product. It's really acidic, so we have to add lime to it to raise the pH. It's too dense, so we have to add perlite to it. It's a dead soil, so we have to add biologicals to it. Our product is much naturally better. It acts more like a biochar with natural water absorption, really good aeration, and a haven for biological properties. So all of the properties of what we do is just naturally better than the competitive products on the market, specifically peat, but also cocoa, corn, wood fiber.
So are those properties introduced during your manufacturing process? Because like, to my understanding, your raw materials, paper and cardboard, right?
Yeah, I didn't understand the first part of your question. You were asking about manufacturing costs?
No, like you mentioned a lot of good properties, right? You have the microbes in it. It's not that soiled. So how do you introduce it during the manufacturing process?
So the key to what we do, we don't add microbes. It's like a biochar. There would not be microbes in it until you introduce a nitrogen source. Any sort of fertilizer that's going to have the biological properties that replicate in our product. So think of our product as a home for that microbial growth. But the paper and cardboard that we use, the key to it is we fiberize it a certain way. We roll it into small twisted balls and peds, and that twisting and rolling process is what ultimately creates this ability for really good water holding, but also aeration. And that's really key to what makes the product great.
How do you get rid of like the unwanted chemicals from the paper?
Yeah, so there aren't any. Our first money into the company was an EPA study using newsprint. People think that there's dioxin and other chemicals in ink. There just isn't anymore. Everything's like soy or vegetable based, whether it be inks or glues related to cardboard. We're also PFSA free. So we've actually been tested for heavy metals, PFSAs, like all of it. We're actually the cleanest soil on the market today.
Thank you, Brian.
Thanks.
Hi, I'm Greg Pushnig, founder and CEO of Boss Controls. We are a system of sort of solutions. We're a standards-based ecosystem at the edge for the power grid. We provide secure communications, control, visibility, and transactions. It's a decentralized system that addresses the change in the grid infrastructure, moving from a centralized power plant to a decentralized ecosystem of networks of DERs at the edge. Three main components of Boss Controls. We're both hardware and software. Our services is a SaaS model, but from a hardware, we provide the only secure IT, OT security for DERs at the edge, zero trust capability, and we have two platforms. We have the DERMS platform, Distributed Energy Resource Management System, in essence, a virtual power plant for utilities, as well as a local marketplace, a virtual power exchange, a Web 3.0 technology that actually connects those DERs to the grid management system and to the wholesale marketplace, but creates a local market at the same time. So how we work with the industry, we provide value both at the end customers, DERs, as well as the utilities. From a utility perspective, we provide them the DERMS. It also allows them to meet FERC Rule 2222 which is a new requirement, and they can be the aggregator of aggregators. And then they can white label our solution and offer it to their customers for new revenues. A big problem with the grid modernization that no one really talks about is the old model of one-way flow of power is dying, and that's controlled by monopolies, and they need to come up with new revenues for a two-way flow of power. We help enable that. So number one, service, because of our edge visibility control capability, as well as transactions, we're able to provide ESG, SEC Scope 1, 2, and 3 capability, 365, 24/7, not only by location, but by device, including EVs. We are able to connect those into a local market and a wholesale market. So we don't just trade power anymore. We can actually tell you what type of power is being used and all the data attributes that go with it. And then equally as important, we're able to retrofit existing buildings in order to get to net zero. Turnkey solution will provide 100% both digitization and electrification at the edge, and we do that with a unique business model. Right now, where we are in the marketplace, we have one major utility working with us. We have one major retailer, partnership in process, and then we have a major telecom working with us as well. And from an end customer perspective, we have one of the largest U.S. cities, Department of Defense, and then the other sort of strategics that are involved in these as well. Right now we have a lead investor, an energy VC for lead investor. We're looking for others to complete the round. Many strategics that are interested in participating going forward. Timing is now. With the change of Ukraine war driving power price changes as well as the IRA, we've seen significant movement in the marketplace, which I sort of highlighted above. Thank you.
There are a lot of DERMS platforms being offered, and how does your solution translate to a more interesting value proposition for utilities and other customers?
Yeah, excellent question. They're legacy 2.0, Web 2.0 platforms. In order to connect all the DERs, both on-grid and off-grid, including EVs, you need a 3.0 platform. So 99% of all those 2.0 platforms aren't going to work well at the edge.
What's your customer acquisition strategy? You showed you have at least one utility that you plan to work with, but have you seen any hesitancies on their side to adopt something like this?
Yes, the utility we're working with has plans in the next 2 to 3 years to roll out both DERMS and a local marketplace. They're testing out our solution now. Key aspect of it is they want a standards-based, fully integrated solution so they don't have to custom integrate it themselves. That's what we are. We're a standard-based sort of solution in the marketplace. So from a go-to-market acquisition standpoint, both the utilities themselves and retail energy, deregulated retail energy providers are a go-to-market, as well as the telecom industry, because we use telecom services at the edge, which is strategic for them, as well as the utilities. Both of them reach the end customers.
Hi, everyone. My name is Steve Moritz. I am the founder and CEO of Incentive Energy. Also want to do a quick shout out. Ecotone mentioned or had on their screens that they were part of the Cleantech Open. I'm a lead mentor at Cleantech Open, and I think Matt Harbar mentioned in the session, any type of accelerator program really can make a difference. We are always looking at Cleantech. I've been a mentor there for 5 years. For companies and mentors. So, there's a lot of success stories even here today from there. So Incentive Energy is a market enabler. There was a lot of discussion earlier today from our keynote about the IRA funds. But what ultimately has to happen is that the people that are either promoting the projects or the people that are willing to fund those projects need to be able to come together, whether those funds are utility rebate dollars or whether they're IRA dollars. So a little bit about the industry. The fact is as Mike Seifert pointed out, energy efficiency has to happen in order for us to hit our carbon reduction goals. There are plenty of energy efficient technology that's in the market today. In fact, most of the energy efficient technology has already been invented and is in the market that could hit this 40% goal. The biggest challenge is that the money that is out there today, primarily the utility rebate money, has historically low participation rate. I'm talking in the teens, like 15, 16% participation rates from their customers, and the administrative costs are in the 35 to 40%. So for every dollar that's brought in, 35 to 40% of it is going towards administrating that money. That model simply will not work. Just to give you a sense of scale, utility rebate programs is a $10 billion a year industry. And think about it, it's been going on for over 15 years, but it's $100 billion just over the last year, over the last 10 years. So when we think about IRA funds, until we can solve getting this money that's out there today into the hands of the people who are doing the projects and the buildings and the customers that are willing to do the projects, we're not going to hit the goals that we need to hit. So we talked a lot about the IRA, and so I'm not going to talk about it anymore, but the fact is that there's big dreams for the IRA program and big dreams for the money, but we're talking about getting into millions of homes and millions of buildings with these funds. But if it isn't working for the utility programs, I'm sorry, it's not going to work for the Inflation Reduction Act money either. So who is Incentive Energy? We started on a mission to figure out how to solve this mismatch of need and funds using technology, to solve the administrative cost problem and to make it more accessible to more people. And we've done that through continuing to innovate with technology that makes that data about what programs through our data set that we call Incentivizer, and I'm going to talk about that in a minute, and offering a range of subscription-based tools to get access to this intelligence and to facilitate getting this equipment, this energy-efficient products into the market and into the buildings and homes. So what is our tech? What is the IP? Well, developed by a CMU computer scientist who has 30 years of expertise in aggregating disparate data sets. We've built over the years. Am I done? Okay. Thank you.
Yeah, I would take these questions to learn more about your actual product.
I'm sorry?
The product. What is the product?
So that's what I was about to say, and I apologize. The data set we've built, it basically indexes millions of products that are energy efficient. Every lighting product by SKU, by wattage, every HVAC product by its SEER rating, every variable frequency drive, every product that is capable of being incentivized is in our data set, and every incentive that's out there for those products is in our data set. And so we continue to able to build on EV products, other heat pump products, and every incentive that comes anywhere in North America is currently in our data set today. And we have thousands of subscribers and thousands of users. You can see we're a $2.7 million company today, 80% gross margin, and 27 now employees that are managing this platform for us.
How has customer retention been with your current customers once they've kind of, the world opens up to them, they see what's out there, they see what you're providing them, and they don't just go off and do it themselves after their subscription's over?
Well, so part of what we saw as being the biggest challenge and is going to be the challenge with the IRA is the last mile. Actually being able to get the incentive once you've decided you want a product. So we've built an e-commerce plugin so that any e-commerce site, Amazon, bulbs.com, that is looking to sell an energy efficient product can plug into our incentive data set and be able to offer that incentive at checkout to a qualified customer. There is no product on the market today that provides that functionality.
What are some of the metrics to show how your customers have been more successful utilizing their utility rebates?
That's a great question. Our first customer base were the product manufacturers. And right now, about 80% of the lighting manufacturers use our tools. And we've had zero churn over the 4 years that we've had them as customers. So while I can't, it's hard to say a customer actually made a decision based on our tool. Once we have the e-commerce plugin moving, we'll have more of that data. But just knowing that the manufacturers of these products consider it invaluable to their sales and marketing has been, I think, pretty strong feedback to the need for this. All right. Thank you very much.
All right. If you've ever had your phone or laptop die in the middle of the day, you know the struggles of battery performance. My name is Alex Sanchez, and I am the CTO of Power3D, a company that's seeking to use 3D printing to change how we manufacture batteries. Simply put, today's batteries aren't cutting it. Performance demands for batteries are ever increasing, and batteries are expected to be widely available and at low cost. When it comes to performance, there's 4 main pain points that we see today. First is the odd shapes and structures of batteries that create unintuitive designs and really bulk up a device. We also see charge rate capabilities where people want to charge their devices faster, as well as cycle life where we want our batteries to last longer. And finally, we want to get more power out of our batteries so we can improve the output and capability of our devices. At Power3D, we're using a 3D printing process to print battery electrodes. These electrodes allow us to create unique structures and designs that can unlock some new design features in devices and allow us to create ultra-thick electrodes which address the energy density and cycle life and charge rate capability concerns. Our preliminary technical assessment has shown that we see a significant improvement in both specific capacity and energy density, as well as improvement in charge rate capability compared to conventional electrodes. At Power3D, we're seeking to become a battery cell supplier that designs and produces electrodes to customer specifications. These batteries can be used in a range of industries, but we believe we're best suited for the wearables and consumer electronics market. This market is growing rapidly, and over the next few years, the expected growth rate is 13.6% each year. And we believe our technology is really well suited to meet the common articulated needs of those customers, specifically more storage, faster charge capability, and smaller batteries for their devices. When we look at competition, we believe Power3D is well suited to compete in this space because our process is material agnostic and can meet the performance levels of some of these other technologies, such as solid-state batteries and next-generation lithium-ion batteries. Our team is a strong balance of business and technical skills. The IP that this process is based off of is out of CMU, and we also have Peter Scott, who is an entrepreneur that has helped us develop companies in the past. So currently, we are a very early stage company. We've developed proof of concept cells, and we're finishing validating our customer discovery through the NSF I-Core program. And we're going to use that information to inform our prototype development as we get into the next stage of our technology. With that prototype, we will work with partners to validate and create a minimum viable product that we can get out into the market. So I appreciate your time and happy to answer any questions.
What kind of material can you print, and then how do you scale it up? Like, it's like battery manufacturing is a huge scale business, right? 3D printing always has like a speed limit. Yeah.
Yep. Yeah, so from a material standpoint, I briefly mentioned, but we are material agnostic, so it is compatible with some your more common battery materials, NMC, LCO, LFP. Sorry if you're, if you're not familiar with those, but the scalability challenge is quite a big challenge. That's kind of why we're focusing more on consumer electronics and wearables to start with. We've done some preliminary customer discovery conversations, and with automotive, they really care about scale and cost. And so to start, we're really not the best fit for that. And so we're looking to get into the electronics market where they're more willing to pay a premium for their performance. And with the technology, it's not traditional 3D printing, it's closer to like an inkjet type print. So it can actually go pretty fast, but to your point, not to the scale that you might see in, or might be required in an automotive type industry.
What's the unique advantage over other companies that are doing 3D battery manufacturing?
Well, we've found that there aren't very many to start. There are a handful, and those companies are typically using other 3D printing processes that are potentially better suited for like solid state batteries, where it's like layer deposition type of processes. And so with our process, we can use current materials, and so that really gives us a benefit in working with what we have right now.
Do you have any early numbers on how much better in terms of cycle life and charging rates your technology is? Maybe I missed it.
So I don't think I have the cycle life in this presentation, but we've done testing on specific capacity and energy density and saw a significant improvement, 200% improvement compared to traditional for specific capacity, 150 for energy density. And so these are starting to meet some of those key targets that we're looking for in battery energy density that we're really excited to keep developing. Thank you.
Awesome, thank you. Hi, I'm Patrick Sullivan. I'm co-founder and CEO of Flux and a chemistry PhD student at University of Wisconsin-Madison. Oh, I used the wrong button. I think I might have messed it up. Oh, there we go. Cool. Okay. So the clean energy transition is well underway. However, this presents a big problem for utilities as we get more solar and wind on the grid. This results in what we see on the left, your right, is the duct net demand curve. As a result, there's a mismatch in value, but this creates a big opportunity for grid energy storage. Recently, we've been deploying short duration energy storage of about 4 hours with lithium-ion technologies that is able to shave off a little bit of this duct, but we're leaving a lot of value left behind, highlighted in red, that there's no technology currently economical to go after that remaining value. When looking at different long-duration energy storage technologies, flow batteries are potentially an ideal technology. First off, they dissolve your battery active material in water, so they're intrinsically fire safe. They're a lot more scalable for grid energy storage, because if you want more energy, you get a larger tank of liquid. But the main point on the right here is they can have long-duration economics because you decouple your power, your kilowatts, from your capacity, your kilowatt hours. The analogy I like to use for this is the driving range of an electric vehicle. For lithium-ion batteries, if you want a battery that drives 12 hours, you need 2 whole cars, 2 whole systems. For flow batteries, if you want a battery that drives 12 hours on the grid, you can get 1 system.
And so this is the challenge my dynamic team out of University of Wisconsin-Madison has been researching. We've built the top innovation flow battery team in the country, and we really have decades of research experience on both the chemistry and battery side working out of our lab. Over the last few years, we've screened all the competitor flow battery chemistries out there. We've developed over 500 alternative molecules, and we filed multiple patents for those molecules. Some of the main ones we focus on are these organic salts that we dissolve in water to store energy, as shown on the left. We've taken steps for taking this technology out of the lab. We've done 1-ton industrial reactions of those organic salts, and we're currently validating their performance in our 1 kilowatt flow battery stack. I don't have time to go into all these details, but there's a lot of grid energy storage technologies out there. They are all ultimately limited by the intrinsic properties of the inorganic metals they're using. With these organic salts, we've been able to circumvent all those historical performance challenges with energy density and efficiency and design these molecules in a way that they're scalable and low cost. What this ultimately does is this unlocks a whole new value regime for utilities and power producer project developers out there. As I mentioned before, we've just been shaving off those peaks, and it has been worth going after the remainder value. But with the economics we're able to hit with our technology, we can capture all that value with our customers. This will result in more capacity value, higher arbitrage value, and higher upside, lower downside on power purchasing agreements. We're currently raising our initial pre-seed round of financing, where we'll continue to build out our core founding team. We need some engineers on the team that can help build out this flow stack technology, and we're currently building our board of advisors that I'm more than happy to talk about on one-on-one meetings. At the end of this pre-seed, we'll be able to deliver this 20 kilowatt stack. I like to think this as our Lego block to building out larger kilowatt and megawatt systems. And then we'll develop really detailed plans for scaling the supply chain with domestic partners. And here's some of the partners at the bottom that I've had multiple conversations that can potentially help along the way. And we're really excited about the impact this technology can have in reducing our carbon emissions with utilizing more solar and wind on the grid, improving energy resilience and equity, which was talked about this morning as well too, with more affordable energy out there, and then having a more secure supply chain for battery active materials in the US. Thank you, and I'm happy for any questions.
What's your expected, and maybe I missed it, what's your expected LCOS?
Yeah, so I have a slide on the economics here. This analysis was done third-party by D&V on the right. We did total cost of ownership. It's a more fair apples-to-apples comparison. And we're predicting we can undercut the cost of competitor commercial flow battery technologies by over 50% once we scale to utility sector. So this analysis was done at 100 megawatts.
What's the size and weight of the storage unit compared to your competitors?
Yeah, so in terms of flow batteries, we have 3 times the energy density, so 1/3 the energy footprint. We can get megawatts hours of energy storage in a 20-foot container. In terms of lithium-ion batteries, that's a little bit of a difficult comparison, but once you take into account all their engineering behind that, it's about on par with grid lithium systems. Great question.
Can you tell me a bit more about the customer discovery you're doing, or what your early customers will be?
Yeah, so really we want to, before any utility contractor would sign with us, like 10 megawatts, 100 megawatts, they want to see this 1 megawatt pilot. There's countless applications you can do with the 1 megawatt pilot, both in front of the meter and behind the meter. We've talked to many microgrid manufacturers who are interested in that application. Also, industry is very interested in that application for manufacturing, data centers, so on. And so there's a lot of applications for that 1 megawatt, and ultimately we want to target utility scale project developers as our end goal.
Okay, last question. So my understanding is that with typical flow batteries, there's this corrosivity problem, and so how were you able to overcome that and figure out this chemistry?
Yeah, so that's one of our key advantages. We use pH neutral water, so it's very non-corrosive. First off, reduces the spillage hazards, but more importantly, as you mentioned, we can use more robust, cheaper components to build out this battery as well, which has been a huge problem, as you brought up. Yeah, very great question. Thank you, everybody.
everyone. My name is Yi, CEO of Teratonics. Today, I'm going to actually introduce our technology to get power from thin air, right? So this is what we're trying to do. So we're trying to generate electricity, just convert ambient thermal energy into the DC power, and we're going to do this indoor and outdoor 24/7. It's very different than the common thermoelectric effects. In this case, that we actually don't need a dedicated heat source. Okay, the power density that we're talking about can be very high. It's a watt per square inch. So with this such high power density, that we can actually think of quite a lot of applications. For example, we can have a self-powered cell phones, and even for larger panels, we can generate utility level electricity. And even the self-powered cars is not completely out of the reach. So the key technology is so-called MSM diode, ultra-high-speed diode. So we're trying to convert electrical oscillation signal in the nanoscale circuits and then rectify them into DC power. Potentially, this device can cost much less than the existing solar panels. So bear with me, this is curve. The red shade underneath this curve is how much energy that's available. Right? Any existing diode can only collect the little dash line on the far left. So that's why it has not been demonstrated, has not been developed yet until we have this ultra-high-speed diode, which is invented here at CMU in my research group when I was a faculty here. So there's patent granted, and we have an exclusive license from CMU. Just touch a little bit of fundamentals. So this is appear to be very good. So whether this is consistent with the physics, right? So recent development in the fundamental physics, both theoretical and experimental demonstration that support this argument. Actually, there are demonstrations that showing that it's totally possible to collect energy even at just room temperature here, right? So the key point or requirement is actually making this diode, and actually the diode that we were just talking about. In the past few years at Teratonics, that we actually spent quite a lot of effort to develop the device design and the fabrication. Actually, we demonstrate the wafer scale IC circuit fabrication, and we demonstrate the completely battery-free IoT sensors. So a lot of this technology actually ready be transferred into making this thermal energy harvesting that we're talking about right now. Okay, so we do have some preliminary data that is supporting this development that is showing nanoscale device can generate electricity. So we're trying to raise 1.5 million for 18 months development for prototype demonstration and validation through third party. So the funding team has a lot of technology backgrounds from R&D and product development and to entrepreneurship and financing and so on and so forth. We think we're very capable to carry out this project. All right. Thank you.
So do you harvest energy from the temperature change or from like the electric background? So
no, there's no temperature gradient necessary.
Temperature, yeah.
No temperature gradient. So at room temperature.
No temperature gradient. Okay.
Right. So there's no delta T. So if you're thinking about the second law, yeah. So this is basically what people have found out that on the smaller scale, the second law is not really defining the system properly. Right? And there are demonstrations that showing that this is actually working.
Can you talk a little bit more about how you're going to commercialize the technology? So who are the target customers and markets, and how are you planning to approach that?
I'm sorry, I missed the first part of the question.
Sure, yeah, just how to commercialize the technology. So
Okay.
target customers and market, and what's your plan for approach there?
Okay, so right now we're at a stage to actually prove through third-party validation and to validate the technology and make the product demonstration. So potentially you can see the consumers' electronics or any people with using energy. right? So we could be just a dedicated company to make an equivalent of battery or power generator.
And will your system completely replace a battery, or will you have to integrate with other battery manufacturers?
That is a good question. So ideally, I think that we would like to have a battery to storage, like a buffer the usage, right? So when the power use is low, this one runs 24/7 continuously, right? But we can, that way we store energy in a capacitor or a battery that we can boost the power, the peak usage. No more questions? All right, thanks.
Thank you. Hello, everyone. I'm George Skopsov. I'm the CEO and founder of HQuest. At HQuest, we have developed a very elegant solution to a difficult and urgent problem, decarbonization of industrial heat. Right now, 90% of the US manufacturing energy supply comes from burning natural gas. We can take clean electricity and crack that natural gas before it's burned into clean hydrogen and valuable carbon. That means that the clean hydrogen can be used as clean fuel to generate that industrial heat, and the valuable carbons can be basically decimate the cost of hydrogen to our customers. There is, by the way, we're only using electricity and natural gas as inputs into the process. We're thinking of natural gas as the hydrogen carrier, so we can leverage the extensive natural gas infrastructure that's available in the United States and eliminate the risks and costs associated with hydrogen transportation. Compared to conventional gray hydrogen, we have no CO2 emissions in our process whatsoever. And compared to water electrolysis, it's a fraction of the cost to build and operate our systems. We need 4 times less energy than water electrolysis, and we do not consume the precious water resources. Overall, with one ton per day system, we can actually eliminate emission of as much as 5,000 tons of CO2 emissions per year. A very important aspect of our technology is the co-product flexibility. Basically, the carbon that we can extract from the natural gas can come in different forms, and we can extract it as engineered carbons going into batteries and energy storage and tires, or we can extract it as synthetic graphite or ethylene. Basically, all of these products have been demonstrated with our research and development partners in the extensive research that we have performed. And what enables all this is our microwave plasma pyrolysis technology. Basically, we pass natural gas through a very small volume where microwaves are concentrated and enable heating of this natural gas at 10,000 degrees per second. So we have very high throughput, which translates into small footprint and low capital cost. So you can actually see our laboratory scale system, our old laboratory scale system in action. The reactor itself is above. It's a very small box where the microwaves are concentrated, and the flame that emerges from that box, it's not a flame. It's actually the natural gas cracking, and the carbon nanoparticles which are forming are glowing white because they're so hot. We have many competitive advantages, but the key ones are low capital cost, no CO2 emissions, and flexibility on the valuable co-products. We have constructed our first demonstration plant. We have tested it here at our site in Pittsburgh, and we're about to deploy it in a paid pilot. Our process economics are great. We can sell the hydrogen directly, basically own and operate, or sell this equipment. In both cases, what we have is basically very low cost of hydrogen delivered, but in a very profitable way. With IRA credits, we can actually pay, the system pays for itself within a year. We have a very strong IP position. It's a well-developed and protected technology, 11 granted patents. We haven't taken a lot of investor funding because we have bootstrapped with the project revenues. And as I mentioned, we have multiple pilots in the pipeline. I have been developing microwave plasma technologies for the past more than a decade. Before that, I was developing robotics technologies here at Carnegie Mellon. And my partner, CFO, is a recovering investment banker. But about a decade ago, he went into entrepreneurship, and he has had 3 successful exits. So I welcome you to join us on this journey. We have built a great foundation, and please talk to me after the session.
Could you talk to us a little bit more about your planned business model?
Say that again, sorry?
Your business model? So,
yes.
Yeah.
So we have 2 business models. One is where we basically sell the equipment to our customers, and they, they generate hydrogen themselves. We support them, so we have a recurring revenue on a maintenance fee. But they also have to find an off-taker for the carbon material, and we can help them in that and basically split the revenues. So it's very profitable for us because they basically buy the equipment. We don't need a lot of capital. It's very capital efficient. The other model is where we own and operate these systems, and our customers is just off-takers for the hydrogen. But then we get to benefit from the IRA credits on the hydrogen production and from monetizing the carbon materials.
How much of the carbon materials are you producing compared to the hydrogen?
It's basic stoichiometry, so 3 times more on mass basis than the hydrogen, which means that it's actually dominating revenue as well.
And then the customer would own the carbon co-products as well?
If they buy the equipment, then they own the carbon co-products. So actually, for the customers that are already in that business, or let's say battery manufacturers or the tire manufacturers, that model makes a lot of sense because then they can generate their own carbon materials.
And in the case where that might not be true, do you help them sell into those carbon markets?
Yeah, exactly right. And we have developed relationships with the carbon black manufacturers and folks in that industry.
Does this process take energy or produce energy?
This process requires electricity because we have to break down the natural gas and we heat stuff. But compared to electrolysis, compared to breaking down water, it takes 4 times less electricity. And of course, it comes with a much more valuable product compared to oxygen, for example. Thanks.
Good afternoon. My name is Shu Chen, and I am the CTO of People's Energy Analytics. We are a company that reduces unpaid energy bills while improving utility revenue recovery. So energy poverty is a huge issue in the US. Currently, there are about 20 million households in the US behind on their energy bills, and this amounted to $32 billion owed to electric and gas utilities at the end of 2020. However, there's also about $200 million in unused low-income energy assistance annually that's not being distributed to households in need. The current utility approach to unpaid bills is to eventually disconnect those customers. And this would mean losing revenue if people don't pay them back, and also putting already vulnerable households at further risk of more heat and cold-related illnesses. So when distributing energy assistance funding, utilities resort to contacting customers on a one-by-one basis. And this method is costly. We estimate that it costs about $450 per customer contacted, and also very ineffective. This is a photo of our CEO in her home over the Christmas cold storm in Pittsburgh, where her tenant wasn't able to pay their bills on time and resulted in a pipe bursting, $15,000 in damages, and also unlivable conditions for months. Our solution to these 2 problems is a proprietary software that identifies at-risk customers at a fraction of the cost. and connect those households to energy assistance before disconnections occur and before heating and cooling seasons. So we have completed a pilot in Arizona with 6,000 households, where we identified 86 households who underconsume energy. And that added up to about 3.9% of vulnerable customers identified at 94% cost reduction. And our cost is about $30 per customer. For a utility of 600,000 customers, this could mean saving up to $3 million annually on identification alone, and also recovering between $1 and $5 million in annual revenue if we get those customers signed up for assistance before the seasons. So our primary targets are the 169 investor-owned utilities in the US, and they serve the majority of utility customers. Currently, we estimate that they spend $9 billion just on identifying at-risk households, but with our solution, we can bring that down to $1.8 billion. Up until now, we have completed our pilot and also verified and published our findings in a high-impact journal. And then through presenting at stakeholder conferences, we've gained 43 interested parties who signed up to our mailing list. And then currently, we're working on our actually second and third pilots, and we hope to launch with our first non-research customer next year, and then eventually become revenue positive in 2025. Our team has experts from all relevant fields. We have energy justice, energy poverty, energy assistance experts, as well as data scientists and system engineers, as well as finance. And our advisors are veterans in the tech entrepreneurial space, and we have greatly benefited from their wealth of experience. Thank you for listening, and once again, People's Energy Analytics is a company that creates a system for increasing revenue recovery of electric and gas utilities while reducing energy poverty. Thank you.
Can you talk more about how your technology identifies the at-risk households and how that's so much cheaper than the current route that utilities are taking?
So we identify behavior markers in usage, and that's proprietary, and that beats calling people. Yeah.
Sure.
How do you get those data?
That we would get that from utility customers that we work with.
So and then the utility pay for you?
Yes.
So what's the cost model, or like the revenue model, I guess?
I think we're still deciding, but we think it would be based on their number of customers that they serve, and also the amount that they are able to recover.
Thank you. How will you continue to keep your competitive moat as people see how great of an opportunity this becomes?
We're patenting everything that comes out of our research group. And then also, I think our research group is recognized as the leader in energy limiting behavior, as we call it. And we have been continuing to research energy limiting behavior markers. And that'll also help utilities better understand future demand, especially in a energy justice context, because we have to account for increased demand from households that have been limiting energy usage, and we want them to be more comfortable by using more energy. So we're a leader in this, and I think we will continue to be. Thank you.
All right, hi, I'm Matt, and I'm the CEO of InceptDB, which is a recent spin-out from Carnegie Mellon, and we specialize in a platform for understanding and assisting with the transformation to green technologies. So these green technologies, outside of being mandated by the governments and the big pushes we have, are very risky for a lot of these different companies and the different individuals that are looking to adopt this infrastructure. We take a EV, which has an average range of about 250 miles, according to the OEM. It can go anywhere from having about 125 miles of range all the way up to about 375 miles of range. This is the difference between traveling in-state and servicing in-state, or maybe into a little bit of Ohio if we look at Pittsburgh, or going all the way to Detroit, or even to New York City. So obviously these fleets have no idea how they can really plan with this kind of variability in the operational range of these vehicles, and so they actually generally restrict their vehicles to only operate about 60% of the rated range, which is showcased by that red circle of our example here. And of course, with this and a lack of overall planning, there's an understanding that the infrastructure development costs and other stuff that needs to be invested in these fleets can be upwards of 4 times more just due to the fact that they're not planning and being able to take into account this kind of uncertainty. And so we look to address these concerns using a digital environment where fleets and all the other operators can understand and really test their services in a digital environment prior to even having to purchase any of the physical assets. This allows them to save on uncertainty costs with experimenting with the actual hardware and really look at what the different options are when they go to do this green revolution. We do this by taking whatever data they have currently, being it telematics data or even just general operations data, injecting it into this simulation environment and bringing in our models where we have both electric vehicle data, battery data, or even other models, and allowing the simulation to then provide what that performance looks like prior to even having to invest in that technology. This allows us to provide planning reports for our customers and also help them with the day-to-day operations, such as when to actually charge these vehicles and how do you deal with the routing of these new kinds of technologies. This is a very growing market, especially within the fleet software side. And of course, as we all know, EVs are looking to dominate within the area, growing all the way up to potentially 30% of the stock within the next decade. And so there are a lot of opportunities for us to apply our technology across the board. And one of the examples we have been getting some early discussions is with Highland, where they've been doing a lot of electric school buses over in the Northeast. And they are actually looking to work with us for getting that electrification report that we mentioned. But ultimately, we are a data company, and we can apply across the board. So some of the different verticals that we can go into span across, obviously, the fleet market, but also utilities and charging providers, where we've had some success with both Rocket Fund. We're actually going to be speaking at the Grid Edge Technology event in San Diego within a few weeks. And we also can span across different technologies themselves. So if you want to do hydrogen, if you want to do propane, we really hope to propel the green revolution and help the adoption of these different technologies. And so our team right now is very young. We've actually incorporated only this past October, but one of the big things that has happened, we're actually looking to sign up with Alpha Lab here in the Pittsburgh area to then propel our technology beyond where we are now and really get through the next validation cases. We've also been going through the national NSF I-Corps programs and looking to continue our customer validation and have been finalists and semifinalists in numerous different startup competitions. And with that, I'd like to thank you for your time, and I look forward to the questions.
So there's a lot of different variables that you can optimize for in these types of softwares, and I'm wondering kind of what the onboarding process looks like for your customers.
Yeah, so what we do is we start off with understanding what they have available from their technology. So if they have telematics data for where their vehicles are actually traveling, the actual routes, the drive profiles, or just know where their customers are operating, that's the first thing we do. So we establish the pipelines to get their data or what they're willing to share within our technology. And we also want to understand, because some OEMs like to use their own models for the power and potentially even the batteries themselves. And so we work to get all that on board, and then it's just about working with them to see what it is that they want to do. Do they want to look at charging infrastructure? Do they want to look at fleet vehicles, how they want to change their operations? It's kind of a very malleable platform in that regard. Then it's just working directly with them to go to that next step, and then once the vehicles are brought on board, we can then work with them to do a ongoing fleet operations with the actual assets once they're purchased.
So it's both for planning and then all like feasibility planning all the way to using every day.
Yeah.
So there are a lot of like competitors on the market. in this? How do you differentiate yourself?
So the ability to go between aircraft, terrestrial vehicles, potentially rail and sea, we can go between that entire area. We can also go between all the different power sources, so hydrogen, propane, natural gas, whatever might come out. We can go across that entire spectrum.
But when you go to the market, you go to the market one by one, right? The customers are basically comparing your solutions with their specific solutions. They are not comparing across the sector, right?
Yeah, but a lot of the fleets are looking to go into like a mixed fleet. And so we provide the opportunity to essentially do all that from one technology. And the other thing is that we have the ability to help with some of these climate reports. So a lot of these companies are starting to give out ESG reports, as they're called. And so having the ability to compare directly to what these different use cases are and what the different technologies will do can actually facilitate with that really manual process right now. And it's looking to actually become regulated that everyone might have to do that. Thank you.
Oh, okay. And where's the? Okay. Hi, everyone. I'm Leah Ohodnicki, co-founder of Sensible Photonics, and our team is ready to make the distributed grid smarter by eliminating outages caused by predictable equipment failures. Power outages are extremely expensive, costing the U.S. economy more than $150 billion annually. They can cost large manufacturers up to $5 million an hour. And as electrification trends increase, so does our need for reliability and resilience. And yet we're seeing a 60% increase in blackouts over the past 5 years. Today's grid has sensing capabilities at the power generation, transmission, and substation levels, but it still lacks intelligence at the distribution level, which creates challenges with improving reliability, resilience, efficiency, and safety in the last mile of service where 90% of failures occur. Until now, cost has been a prohibiting factor, but with Sensible Photonics sensing design capabilities, we are able to produce a sensor that is able to be deployed at the distribution level. So how do we do it? We know that failing transformers overheat over time. We also know that they display abnormal acoustic signatures. So using this information and our patented fiber optic sensors, we're able to create a patented sensing design that allows us to use a low-cost light source in place of typically expensive lasers, a fiber optic sensor where the light transmits through a hair-like strand of glass, so it provides us flexibility in how we deploy the sensors into the distribution assets. That light sensor connects to a lower cost detection circuit, which then connects to existing asset management tools using existing network connections. We're targeting distribution assets as our beachhead market, which represents a $55 billion market opportunity globally for us and an $18 billion market opportunity in the US. Our customers are OEMs who will be looking to embed the sensors into their equipment, as well as utilities looking to retrofit. We recognize retrofitting is not ideal in terms of a deployment, so the longer-term strategy is to embed these sensors into the OEM devices. We also know that the sensors are going to generate valuable data, and we'll look to monetize that data in the future. We have a proven team with the experience to succeed. I'm joined with co-founder Dr. Paul Ohodnicki, who has been in the energy sector for over 10 years now, previously worked for the Department of Energy and now is at the University of Pittsburgh. Also, we just brought on John Balachek as our CEO. He's an experienced startup executive with focus in the sensing realm. And Dr. Nagesh Lalam is also a co-inventor on the technology and will be joining our team. We're seeking $350,000 to support our MVP prototype and pilot, and we will look to scale in the future so that we can build to a $30 million revenue target by 2027. I'm excited to talk to you all. If you can help us achieve these milestones, please sign up to talk with me. Thanks.
What's the cost to the OEMs to fit the sensors on the distribution assets?
So we can produce these sensors at $100 a piece. We'll look to sell them for $300, and that's really what differentiates us from competing technologies that have attempted to deploy these sensors in the past. The competing technologies can be upwards of $10,000.
Can you double click on the technology itself?
I'm sorry.
Can you double click on the technology itself? Like what's the actual technology and what kind of things are you sensing right now?
Yeah, so the technology is a fiber optic sensor, and it's able to be embedded into the equipment so that you can put it into harsh environments without any of the circuitry kind of creating issues. It is sensing the temperature changes, temperature fluctuations, as well as acoustic changes.
What kind of metrics will you use to determine a successful product?
Yeah, so this is an ongoing challenge in the space, and as we've talked on our customer discovery conversations, we recognize that when they are looking to measure ROI, there's a lot of different factors that come into play, and we will be an enabling solution for them, and we'll be looking to work with them to identify KPIs that will help them to achieve their goals, but also recognize it can be a challenge when they have a number of different solutions that they're deploying at the same time.
Have you begun speaking with OEMs, and how are those conversations going?
Yeah, we have had some early conversations, and a lot of the research and development and funding that funded the development of this technology was with OEMs. We know that OEMs are looking for utilities to say that they need and want this technology, and that's why we've been having a lot more conversations with the utilities to really start to gain that buy-in. Thank you.
It should work for these. It's great to be at the end, huh? Hello, everybody. I'm Randy Eager, co-founder and CEO of Silicium Tech. We are a Carnegie Mellon spinoff, and we are focused on rebuilding the U.S. Solar supply chain. Our unfair competitive advantage is thanks to Eric Yitzy, who's here with us today. We are able to produce silicon wafers at half the cost compared to traditional methods today, and probably just as importantly, with less than half the amount of CO2 as well. So let's look at the solar supply chain now. I think everyone knows that this is a very difficult landscape for the U.S. Today, it is the truth that the wafers and cells are produced elsewhere. There's not a single manufacturer here in the U.S. We intend to fill that gap. And let's look at the size of the market. It's a $6 billion opportunity for us to fill that gap. If you look at the graph on the left, these are either installed base of nameplate capacity today or proposed in the future. Looking on the left, these are cells and wafers. You can see how small 13 gigawatts worth of production capability When you look at the modules, it's obviously a much larger size, about a 39 billion gigawatt, 39 gigawatts of capacity. If you look at the 39 out in 2027, the $6 billion gap here really is every single gigawatt is 200 million wafers. So this is extremely large opportunity. So a little bit more about what the continuous process is that I was mentioning. Current process, maybe many of you are aware of, a very large bowl of a cylinder of silicon is produced. It works great for the industry, for the chip industry, where they work with round wafers. Our solar industry works with square wafers, which means plenty of cutting and sawing, and actually 40% of the material is wasted. Our process is continuous. We make exactly the right width and the right thickness with no waste. Significant tailwinds, we've talked a lot about Inflation Reduction Act. It actually would reduce our costs by about 30%. So really supportive of that, of course. But solar is definitely in favor. 70% of our future installs in the next 3 years will be solar oriented. So it's great tailwinds for us. And this is a really experienced team. I've done, this is actually my 5th Carnegie Mellon spinoff. Really, my early days were at BASF, building a business unit there. Nearly all of my companies have been in the materials world. Eric, who you know about, Carnegie Mellon professor, inventor. Michael, the next person over there, is our COO, big company process guy. John Izos is a great industry veteran. He's built a couple of plants, a couple of module manufacturing plants, so he's fantastic. John Holder is our real industry veteran when it comes to materials. He's an expert on producing monocrystalline silicon. Thank you for the opportunity. We are a pre-seed company. We're raising $500,000. Early money in was thanks to DOE. The group won the DOE Made in America, round 1 and round 2 of that. We have hard-circled the first 100,000 of the 500, and hope that you can join us.
What's the defensibility of the process?
Oh, now I see why people had a hard time hearing you. I couldn't hear you.
Sorry, what's the defensibility of the process in terms of patents? How protected is it to ensure that competitors, especially considering many of them are international, aren't going to just undercut it?
Yeah, this is a longer story, but actually people have been working on this since the 80s. So there's a tremendous amount of public patent work on this. Eric has spent 10 years, about $5 million in NSF and DOE grants. Starting at that point was, why didn't this work? So he's come up with the reasons why that hasn't worked, and we're scaling those now.
Sorry, yeah, since it was a specific questions on the patent, so we filed for the application 3 years ago. It's worked its way through the final office action, and the patent will be issued in June, they promised, this summer. So I think we're well protected as far as this is concerned.
Yeah, thanks, Eric. 2 patents.
So does this technology only work for like polysilicon? Like what about like the monocrystalline silicon?
One more time, sorry.
Sorry. Does this process also work for monosilicon?
Yes, definitely monocrystalline.
Yeah.
Usually the question we get is, does it work also for chips or microelectronics? And the bar for that is much higher. To produce our wafers for the solar industry, it is a much easier bar or requirements to meet.
That is the end of our time for this. Let's give thanks to all of these companies who got out there. It's really tough to tell a complex story in 4 minutes. So they did a great job. And I really want to thank our panel here, just staying on point here to all these different things and not just feeling overwhelmed. It is amazing to do it for that long. So round of applause, please, for our panel.